I got the challenge from my daughter. It has a name. It's called Instance Insanity. The challenge she did from paper 4 cubes, and each side of the cube, each face is colored with one of the colors yellow, red, green, or blue. So I have 4 cubes like that, and I need to place them as a tower in a way that once the tower is there, every side of the tower has all the 4 colors, and the challenge is built in a way that there is a solution, but there is only one solution. So let's look for a second. So this is the challenge. You have 4 cubes. It's not important which one I place first, which one I place second, because the only thing that matters is let's agree that this is the front. So on the front you have 4 colors. So now this doesn't hold because we have here 2 greens and we don't have a yellow. This also doesn't hold because we have 2 reds, but we don't have yellow. And apparently, if you arrange the cubes correctly, there is a solution. You just need to look for it. For human, it is challenging, and it's the name is appropriate. Insanity. You after trying many trials, you lose your mind. For computer, it's not that hard. There are not so many options. Let's say without taking into account symmetry, so maybe it's 24. I think it's 24 configuration per cube, and then to the power of 4. Probably less because of symmetry, but the computer can do it, and this is what I am showing here, and this is exactly what I did. I have a class that represents a cube. I initialize it with a very explicit dictionary of all the sides, all the faces, exactly what color they are. Maybe there is a more concise way to do it, to represent a cube. There is, maybe I'll say a word about it, but here I just gave it very explicit. Also, when I rotate a little the cube, I used yaw, roll, and pitch from some image I saw on the internet, and these terms is what I used, and you pass here 0, 1, or 2, and this changed the rotation, and the implementation that I have is just a loop with the specific transformation. Probably there is a better way to write it, but this is not the issue. Then I have the problem. I initialized hard code with 4 cubes. What starts here at the top is going to be shown. The bottom, yellow, red, red. So yellow comes for the top, red, red. So yeah. So I initialize the problem, and then I ask, is it a solution at the moment? What I'm going to do is I'm going to mutate the state of the problem. So I'll make a change, then I'll ask if it's a solution. The code is not great. I'm not sure this is an example of a nice design, but just showing the solution for this specific problem. I have an instance of the problem. If I want to make a change, I actually access the internal, should be private variable cubes, and mutate them. I have a plot which shows it shows in a grid, it shows that the bottom cube is the first one, and so on. And this will be what I call the front. This is the top, bottom, and I can, because I'm using a Matplotlib widget in a notebook, I can even, and I follow the installation correctly, I can even rotate it, but this one is just, it doesn't change the object itself, you just look at it different. And then I ask, is it a solution? It's not at the moment. Here I just examine the implementation if it works. It seems to work. I have here, again, I'm not terribly proud of the implementation, but managed to solve it and demonstrating just a solution. I have all the orientation. If I got it right, then this, I think it's 24 orientation, and I think this is a kind of reasonable way to achieve that. This is a generator that I later need to use to call the function change orientation. And here I brute force try everything. And when I do find the orientation that is the solution, then I print found and exit. It runs. This is strange. Why the wall time is less than the CPU time? Don't know. Anyhow, less than a second. And then this is a solution because the front has all the four colors. This is right, all the four colors. And that's it. Maybe I want to say something. The original problem is very interesting. If you want to find YouTube how to solve it, search for instance insanity. Apparently you can represent every cube as a small graph between the edges. The nodes are the colors, and the edges are between colors that appear on opposite faces. So let's say I have a small graph for that one, blue, yellow, red and green, and the matching edges. I have another small graph for that one, another small graph for each of the cubes. Then you collect them into a single graph. If there is an edge that appears in more than one, then it will appear only once. But you right next to the edge, so each cube has a name, like 1, 2, 3, 4. You'll write next to the edge the name of the cubes where you saw that. And then there is another step which you select from that graph. You select which edges you're going to use. The one that have 4 that were indicated by all the 4 cubes or something like that. Maybe I missed the small detail. So analytically it's very nice, and it's nice that you can represent a cube with this graph. Yeah, I started when my daughter told me about this problem, my head went in the direction of reinforcement learning or search or something. Yeah, but it's for a computer, it's just brute force and do something and it will work. But it was nice. What I didn't manage to do, I wanted to draw the 4 cubes together. I plan to have it here next in the grid, and so I will be able to roll them together, but I did not manage to control the colors of each voxel. This is a voxel. To have 4 voxels standing one on top of the other and control the colors of each one of them, I didn't manage to do it. So this is where it ended, but only with the individual cubes. Thank you very much.